100 years ago, Victor Hugo wrote, "Where the telescope ends, the microscope begins. But which of the two has the grander view?" Today, we still seek the answer. A Fine Science with Holly Preston.
SED Systems Incorporated, located in Saskatoon, is a high-profile company that's in the forefront of many technological developments. From humble beginnings as a division of the Department of Physics at the University of Saskatchewan, SED has moved on to design and build Canada's first space shuttle instrument. It's called WAMDI, and we'll be looking at it later in the program. Another SED development we'll look at is called SkySwitch. It's a telephone satellite system that's revolutionizing communication in remote areas and isolated communities. A third SED development we'll look at is a little more down to earth: electronic monitors and controllers in farm machinery. The last story on this program concerns a linear accelerator lab, another spin-off of the physics department of the University of Saskatchewan. The lab is still on campus and presently undergoing an upgrading to bring it back up to a world-class facility. But first, WAMDI. SED Systems Incorporated in Saskatoon has designed Canada's first space shuttle instrument. The project manager explains what this very complicated equipment will do once it's orbiting the Earth.
Now what the instrument does that we're developing, which is called a WAMDI, or a wide-angle Michelson Doppler imaging interferometer, is that it measures specific aspects, in particular the movement of gas in this region and the temperature of that gas. In other words, it measures the winds and temperatures of the upper atmosphere. Well, the two major components are a large piece of glass, which is referred to as a Michelson interferometer. It forms the heart of the system, and it's a very specialized piece of glass. It's manufactured to tolerances measured in millionths of a meter. It's made of 3 pieces of glass. The whole thing weighs about 25 pounds. And it forms, what it does is it takes light from the atmosphere and produces interference fringes, which are then imaged onto the next component, major component in the instrument, something called a charge-coupled device camera, which is a specialized silicon chip that produces an image of the interference pattern produced by the Michelson. The way the charge-coupled device camera works is or CCD camera, is it uses a chip that has over 88,000 photoactive elements, each producing a signal proportional to the amount of light that's falling on that photoactive element or pixel. These pixels are exposed much in the same way as a normal camera is for a few seconds, and then electronically read out and transmitted to the ground. The advantage is that you don't need to ever change the film. Of course, that would be difficult to do with a shuttle instrument.
You did some field testing, and you got some images from that also.
Yeah, our test program was threefold. Field testing was a very important part of it. Before we went into the field, we spent 3 months characterizing the instrument here in the lab. Then in February of '84, we went to the field for 3 weeks to look at the actual emissions from the sky. The emissions that we observe with the instrument cannot be produced on the ground, or not very easily produced on the ground. So there was a requirement to calibrate the instrument against the real sky. Also, the instrument will not fly for several years, and the scientific community would like to have an opportunity to get some experience with the data. And the third part of our test program was to take the instrument to David Florida Labs in Ottawa, which we used for vacuum testing and vibration testing of the instrument. Of principal interest, I think, is that of weather forecasting. There are processes occurring in the upper atmosphere that affect what happens to the weather at lower regions of the atmosphere, which of course we're interested in. And weather forecasting is a very difficult science, partly because there's a lot of variables that can't be precisely measured. Scientists will say if they can better understand and better measure the characteristics of what's happening in the atmosphere, we will have better weather forecasting capability, both short-term and long-term climatological predictions. So one benefit is that the data can be used in global weather models that now exist in various stages of development in an attempt to better understand how weather works and how what happens in the upper atmosphere can affect the lower regions of the atmosphere. The other area is that of an opportunity to study a plasma. The upper atmosphere is a plasma which exists in a container. It's a containerless plasma, and there are effects, scientific processes and things that can't be studied or reproduced on the ground that scientists have intense interest in. Some of them related to things like controlled fusion and those areas of research. The WAMDI will fly on the space shuttle. It sits in the cargo bay of the space shuttle, and it flies for durations of up to a week. It's designed to fly 10 times. Right now, we've just recently had word from NASA that the launch date will be in 1989. We don't know precisely when in 89, but we're talking probably before the middle of 89.
Besides WAMDI, SED Systems is in the running for another project called WAMDI. That instrument will be aboard an American satellite and will also measure properties of the upper atmosphere. Because of its experience with WAMDI, the company should have a good chance at the $13 million WAMDI contract.
This week on Countryside.
Keeping the farm in the family is not as easy as it sounds. Meet a couple who have given up the family farm for a new career. And swamp fever, a horse owner's nightmare.
Watch Countryside, Monday at 7 on CBC Television, Regina.
Nick returns to Greece to help a friend, but Relic is in the way, so Nick has a plan.
You're going to stir up the pot a little.
A Beachcombers special hour tonight.
You're acting like a jerk who thinks he's really cool.
Toby's got something to prove.
No! One thing after another with you.
He's going to prove all of them wrong.
I'm racing to win.
Toby McTeague, Best on the Box, tonight on CBC Television.
As we mentioned at the beginning of the program, SED Systems is involved with another venture called SkySwitch. The project is revolutionizing communications in remote areas and isolated communities. And it all starts with a piece of equipment that's very familiar.
The telephone is probably the most common piece of technological equipment in use today. It's taking on a new dimension, however, at SED Systems in Saskatoon, where development called SkySwitch is providing companies with their own personal communications operation.
It provides for telephone conversations and or data communications from any location within the broadcast range of the satellite to any other location within the broadcast range of the satellite.
Using the Annex C satellite, a construction company in Saskatoon is linked directly with one of its offices in Eagle Plains in the Yukon Territories, just 30 miles south of the Arctic Circle.
Good morning, Eagle Plains Hotel.
Good morning, Pat. It's Brian from SED calling. How are things up in Eagle? I'm very well, thank you. And how are things in Eagle Plains this fine morning?
Well, we're having a bit of rain today.
In Canada, there are a lot of organizations which have two basic criteria. One, they have more than one location at some distance from each other, say a head office in Toronto with branches in Calgary, Regina, Vancouver, Halifax, wherever. And they have communication needs between these. These people can benefit from a satellite communication system. Other people who have needs to communicate to the far north, petroleum companies, people such as McDevitt Construction, mining companies, aircraft or airlines, all have requirements to communicate from the populated southern belt into the remote north. These communications right now are well nigh impossible through the telephone system. They have to rely on radio, which is of low quality and oftentimes interrupted either through mechanical failure or through environmental interference to the radio systems. These people are also candidates for satellite communication systems. Here at SED, we're involved in the design, manufacturing, sales, and service of various high-tech systems, such as SkySwitch. We are looking here at a number of systems which are currently under construction. These systems are intended to, or will be shipped over the next 2 to 3 weeks to Manitoba Telephone System and to Telesat Canada, both of whom are establishing satellite communications networks based upon the SkySwitch product. These systems are being integrated. Previously, we have built the modules that you see here and are now integrating them into the chassis for final assembly and test purposes. From here, the systems will go into a test phase, which lasts approximately 2 weeks. They'll be run through a heat chamber to determine and detect early or heat-related component failures. They will then be run on the shop floor for approximately 3 days, at which time, having passed that successfully, they will be packed up and shipped off to the customer.
Well, have a good day, and thank you for calling.
You're very welcome. Have a great day. Bye-bye now.
You too. Bye now.
Not all of SED Systems' projects are as glamorous as satellite technology, but some are just as important. For example, the company has developed a line of electronic monitors and controllers for farm machinery. As farms became larger in the 1950s and 60s, equipment became larger as well. In the 70s, farm equipment and size mushroomed. Since labor on a wide scale was no longer needed, various firms began to produce electronic devices to help the operation. SED Systems became one of the leaders.
Okay, the grain loss monitor is an instrument which SED manufactures for use on the combine for purpose of detecting crop which is lost at the time of harvest. Now, how the grain loss monitor works is primarily on the basis of some sensors, these particular sensors being unique of SED manufacture, but sensors which will be mounted at the rear of the combine at along the trailing edges of each of the sieves and the straw walkers of the combine. As material leaves the combine, the straw and the chaff will also strike these sensors, but should there be any grain in this particular material leaving the combine, it will strike the sensor, and such as you see here, just a few kernels of wheat striking the sensor cause a fairly drastic movement of this needle. There you see as the kernels have stopped falling on the sensor, the loss falls back to zero. The operator can keep an eye on this instrument as he is harvesting on his way down the field, and should he see an undue amount of loss starting to occur at any particular time, he may initiate corrective action, such as reducing his forward speed, perhaps increasing his forward speed, or in a more overall sense, perhaps make some adjustments to things like the concave, the cylinder setting, fan speed, or so forth on the combine. This particular grain loss monitor has with it also a speed sensor. This leaves us the option of doing what we term a time-based measurement, which might be related to something like bushels per hour. That is the number of bushels per hour these few kernels of wheat would represent as we harvest, or what we call area-based measurement. In area-based measurement, we take recognition of the signal from the speed sensor on the wheel, recognize that the combine is moving further and faster down the field, and in a sense might be thought of as measuring more of a bushels per acre of loss. This particular grain loss monitor is microprocessor based. This gives us the multifunction capability of not only providing each of the time and the area based loss readouts, but also such things as a precise digital readout of ground speed, things like area measurement, distance measurement, and other items which are of interest to a farmer while he is harvesting.
If a farmer is using an airflow seeder, SED Systems manufactures sensing devices to let him know that the equipment is operating properly.
As material strikes the little pin of the sensor, a signal is generated which operates the circuit of the CEDR monitor. Should at any time a blockage occur, the signal will no longer be generated, and the operator will be alarmed of this blockage that has occurred in his machine. Likewise, we also provide a bin level sensor which is located in each of the seed and fertilizer bins. As long as this sensor is fully covered by seed or fertilizer, the circuit will detect that there is material in the seed tank and provide a normal operating status signal to the operator. The part of the CEDR monitor which the farmer has in his cab, the part which provides the information as to the number of blockages, the location of the blockages, and nature of other irregularities, is a control unit such as this one. We'll see as it is turned on the flashing of some lamps to indicate the location of the blockage. Also, you heard a brief audible alarm. The purpose of this alarm is to alert the operator that there has been a problem. He is probably looking at other things as he is going down the field, and this brief alarm provides purpose of causing some attention to look at the nature of the blockage.
Spraying operations, often regulated by hand controls, can be simplified with a remote control system.
We have a simple toggle switch which operates a little butterfly valve, which we have here in a cutout fashion so we can see the actual butterfly. This butterfly is located in the supply line that is supplying chemical to the booms of the sprayer. Adjustment of this butterfly may be used to influence the working pressure of the sprayer. This particular piece of equipment, the pressure is indicated on this gauge right up within close eye shot so that the operator may have a detailed look at it at any time. Other features of the remote control system include switches for the operation of solenoid valves. This feature is of particular interest to a farmer as he is finishing up a field and may find that he does not want to operate the full width of the sprayer, in which case simply turning off one section narrows himself down to a more effective means of finishing up irregular shaped pieces. Similarly, we provide a master switch so that simply by turning one switch, the farmer can immediately deactivate the entire system at the end of a field, for instance.
A farmer can go one step further with monitors that tell him if the sprayer is working properly, and even further with rate controllers that work with the monitor and actually apply the right amount of spray.
The products we've just seen are only a few of the many available. The future will likely see greater advances in field guidance systems and greater reliability on electronic components. Onboard computers to make operational recommendations or actually perform the functions will become commonplace.
What's green and white and the hottest thing in sight?
It's the super incredible H-Team.
The one and only 4-H Club. It's a hit, it's hot stuff, it's having your say.
Home computers, home baking, a home run a day.
It's homegrown hiking, it's a great head start.
It's hands-on, healthy, and heart-to-heart.
It's hobbies and horses and showing them how. It's everything you want and it's happening now.
Call us and discover the new 4-H Plus.
Hang in with the H-Team and grow with us. The one and only 4-H Club.
Heart attacks don't have to take so many lives. With enough people aware of heart attack signals and trained in CPR, thousands of lives can be saved each year. But an adequate emergency medical system is also needed, or these citizen efforts will not be as effective. Make sure you have a good emergency system in your community and learn the other steps for survival. Read Heart Steps, a new brochure from your Heart Foundation.
The true dining experience. Enter the fabulous world of the Brown Derby family restaurant with its tradition of great steaks, extraordinary seafood, ribs, Greek, Italian, and gourmet specialties, and the Super Sunday Brunch. It's your best choice, offering the largest menu in Regina at the right price. Relax or enjoy the soft sounds of live entertainment. At the Brown Derby, everyone is treated as royalty. Experience the Danakas touch. The Brown Derby family restaurant, a true dining experience. 3926 Gordon Road.
DeFair's year-end markdown is on now. Look for this flyer and you'll find
Have you seen DeFair's flyer for their year-end markdown sale? It's filled with store-wide savings on sofas, chairs, love seats, dining rooms, bedrooms, and appliances. And there's no down payment. No payments and no interest till August 87.
Yeah, you see...
You've seen the flyer.
I've seen the flyer.
You've seen the flyer.
DeFair's year-end markdown is on now, only at DeFair's.
You've seen the flyer.
I've seen the flyer.
The projects of SED systems are tangible, but not so with the Linear Accelerator Lab, another offshoot of the physics department at the University of Saskatchewan. The lab conducts research in the area of nuclear science, not to create an end product in itself, but to add to the bank of world knowledge in the study of the nucleus of the atom.
Very important to realize that we're not trying to solve the world's problems here. We're not trying to make a better widget or cure any disease. We're studying the structure of the atomic nucleus just to satisfy our human curiosity. We want to know what's in the center of the atom. And just as an astronomer has to build a big telescope to look far out into the universe, we have to build a machine that's essentially a big microscope to look at the center of the atom, the atomic nucleus, what it's made of, what particles are in there and how they move. Carbon's a nice circular one, nice and easy to begin with, but you can have any kind you like, praseodymium, neodymium, palladium, all these obscure things, so all kinds of targets. The machine is essentially like a big radio transmitter with a rather peculiar antenna. Where the antenna would be in a radio transmitter, we have a source of electrons, which are subatomic particles, and these electrons ride on the radio waves like surf riders on a Hawaiian beach. And these electrons gain energy, they become very close to the speed of light, and when we've got them up there, we bang them into a target, and we smash the nuclei of the target with this electron beam, and by observing the subatomic particles that fly off when we've smashed the nucleus, we try to piece together what existed before we smash it. It's a destructive way of testing, but we have no choice because these things are too small to see directly.
Who would be using your equipment over a period of time?
Well, initially the people who built it are going to have first priority to use it, but we already have users from other Canadian universities who are bringing their own detection equipment to use our beam, and we hope in the longer run to attract people from the United States and even from Europe. Indeed, this is a very international operation that there will only be 2 or 3 machines of this particular type in the world in the next 10 years, one in Germany, one possibly in the United States, and one here. And so we're expecting teams from all over the world.
Where might this area of experimentation take you in the long run?
Oh, I think that what physicists hope someday is to have a unified theory of fields. That this is very, very obscure stuff, but at the moment we think of the forces of nature, like gravitation that keeps our feet on the floor, and electromagnetism that makes this television set work. The forces that hold the nucleus together are all sort of separate. And the ultimate goal of physics in this century is to combine all these into a single picture. Now, we don't pretend to be contributing a big piece to this picture, but to complete the picture you need all the little pieces. It's like a great painting, and every scientist, every nuclear physicist is contributing a little bit to that painting. Some of the huge accelerator labs in the world may be doing very important parts of that picture, and we may be doing less important, filling in the background, painting a little bit of a robe or something like that, but each part is necessary for the complete picture. We tend to justify this type of experiment to governments and to politicians in general by saying that we're going to give all kinds of new goodies to society. And in the past, it has been true that pure research has paid off in many areas. But you never know whether it's going to pay off or not. It may be that our research may have some practical application. But if it doesn't, it's still there satisfying our curiosity, which is the real motivation.
This program has looked at two very different approaches to research, but each is on the cutting edge of its field. One studies the nucleus of the atom, recording its findings to satisfy a scientific curiosity. The other designs and manufactures high-tech equipment to try to survive in a highly competitive marketplace. Both have their research down to a fine science. I'm Holly Preston. Thank you for watching our program.
This is CBC Television.